You're talking about these parentheses? Okay, what goes here in a lambda expression is its formal parameters, the names of its arguments. So if you have open paren, closed paren, that means it's a procedure that doesn't take any arguments. Like down here, when I called C1, I didn't give it any arguments. Right? Does that answer the question? I'm not sure what you mean. When you say it returns, what it are you talking about? The lambda, every lambda returns a procedure. And every procedure has a formal parameter list and a body. The formal parameter list can have any number of formal parameters, including none. What's the purpose of using? The purpose of lambda is to create a procedure. We want to be able to invoke C1. Right? So down here, when I wrote this, what does this mean when you say that? It means, whoops, sorry, I clicked a button without meaning to. So what does that mean? No, I mean, what does it mean when you type to scheme, open parenthesis, C1, close parenthesis? What? Yeah, invoke C1. So C1 has to be a procedure, right? Where does that procedure come from? It comes from here. Now, why does it come from that one? Well, this outer one, that's the procedure make count. So the outer one actually includes everything all the way down to the end, like this. Okay, that's the procedure make count. I invoked that one at the beginning when I said define C1 to be the result of invoking make count. Okay? So that's why that first one isn't C1. This one isn't C1 because when you call make count, it doesn't just say return the value of this lambda expression. It says call this lambda expression with the argument 0 and then return whatever that returns. Okay? Well, so that's the let. So what does the let return? It returns the value of its body, which is this lambda expression. So this is the thing that we define C1 to be, is the value of this lambda expression. Okay? So the important new thing is that C1 isn't just this lambda expression. When you evaluate a lambda expression, you get one of these things with two bubbles, the first of which is essentially the lambda expression itself, the second of which is this other thing called an environment that we're going to talk about. Okay? Yes? What if you had the lambda result and you didn't have this lambda here? Then when you called make count, it would do all of this stuff. You don't want to do this when you call make count. You want to do this when you call C1. Right? Yeah. Yeah, good question. The question is, why is making a procedure coupled to making an environment? Actually, technically, you'll see that that's not the case. When we actually talk about how the model works, making an environment comes from calling a procedure. But the real answer to your question, which is a deep, good question, is that environments are not visible things in the language. Okay, it's not a data type with selectors like what's the value of this variable or anything. A scheme user does not see environments. In fact, we've been using environments all along, completely invisibly to us. So what we see is not environments. What we see is procedures. It didn't have to be that way. You could imagine designing a programming language the way you said. All I can tell you is 50 years of Lisp experience have shown us that this is a system that's really, really, really useful. Okay? So one of the things it lets us do is this business of making persistent local state variables. We get that free. And that's a thing, I think I said this last week, but I want to emphasize it again in the context of this week. All those other languages, they think that you need special object-oriented features in your language in order to do object-oriented programming. So there was C, and C wasn't object-oriented, so they made it C++, adding object-oriented syntax to the language so that you could define classes and things. We did the same thing last week. We made sort of Scheme++. But the point is you don't have to. That Scheme wasn't especially designed to be object-oriented. It was just designed to do the right thing. And object-orientedness happens to turn out to come out free when you do that. So if you talk to old Lisp hands about object-oriented programming, they all wave their hands and say, oh, objects are just closures. And what a closure is some way of representing which variable do you mean by this variable name in this place. And that's an environment. So all an object is, they're saying, is an environment. And that's true. All an object is an environment that contains instantiation variables, instance variables, class variables, methods, all that stuff have to be in the environment. And that's an object. Right? I don't actually offhand know of a language in which environments are actually user visible. Do you? Is there a language like that? Yeah. Recent versions of Scheme actually do have environments as a data type, but they only give you the global environment. And if you're lucky, no, not even if you're lucky. They give you the global environment and the even more global environment that has the initial values before you do any defines. Those are the only things that you get. You can't get any sort of local individual environments. And the reason for that actually has entirely reasons about compiler efficiency, or rather the efficiency of compiled code. If you keep the user's hands off the environments, then you can compile Scheme programs on the basis that the compiler knows, before the program is even run, what variables are in what environments, where to look for a particular variable, as seen in a particular context. So when you compile something like our count thing, and it says result in here, the compiled code doesn't say, look up the name result. It says, take the first variable of 2 environments back from here, or something like that. And that makes things much faster. Whereas if users can change environments on the fly, then the compiler can't make those assumptions, and the programs are a lot slower. So that's really why they do it this way. But it turns out to be good enough because we can use a procedure to represent an environment, and that's what let does, basically. Let says, I need to make an environment with this sort of local variable in it. And you could imagine having a make environment primitive that would do that and that would be used by let. But instead we just say, make a procedure that has this local variable in it, and then call the procedure. And that's, it's sort of 2 features for the price of 1, in a way. Okay, but good question.